Welcome to this series of operations management. Today in this series we are talking about process design, various kinds of processes. In the last session we had studied about various kinds of processes like continuous process industry, we had studied about batch process industry, we were talking about assembly line technology or assembly line technology processes, we'll be talking about job shop processes, we'll be talking about project type processes. So in assembly line technology, if we see what is assembly line technology, it's a process technology suitable for a narrow range of standardized products in high volume. So this kind of process design is used for products like automobiles, consumer durables like televisions, refrigerators, washing machines, microwave ovens, dishwashers, etc. Let us see what is the formal definition of a flow shop processes or assembly line technology. So these are organized around a fixed sequence of activities and process steps such as an assembly line to produce a limited variety of similar products or similar goods or services. So as we have seen in our last session, so these processes have a defined route. Only thing is that there are assembly lines. The product moves in an assembly line, and then finally there could be a variation in the final version, and then it can follow a different route. So first of all, the product will travel in an assembly line, and then it may bifurcate into different lines. So for example, there is a car, there is one model of the car, so it is manufactured on a line, but afterwards there are various variants to that car, so it may follow different lines. So such kind of processes are called assembly line technology. What are the other characteristics of such kind of process? Little or no setup time, it's dedicated to a small range of goods or services that are similar sequence of process steps, and there are moderate to high volumes. Examples: assembly lines that produce automobiles and appliances, production of insurance policies, and checking account statements, and hospital laboratory work. So as we have discussed earlier, that such kind of systems are called assembly line systems, wherein a product you can make only say automobiles in an automobile industry, so you have to make your assembly lines accordingly. If you are making a refrigerator, so accordingly in the assembly line you will have the desired machines in between, you have the desired infrastructure and paraphernalia in between, and finally it may join another assembly line. So for example, a compressor, for example, if you are making a refrigerator, in a refrigerator the compressor is made on one assembly line, the body is made in another assembly line, the condenser is made in another assembly line, and other accessories are made in another assembly line, and finally all these assembly lines will join together to assemble the final product. Now we come to another process which is known as job shop technology or job shop process, a process technology suitable for a variety of custom designed products in small volumes. Many times you might have heard about this word job work. So what is job work? Job work means an industry is having some machines and the people come give their material to make, so and this industry only charges the making charges from the customer. The material may be of the customer, so that is called job work. So on that basis we have this process called job shop technology. So here it is not necessary that the material will be given by the customer or by the client. The material may be used by the industry themselves, but they are taking custom orders from the market. So whatever from their client, whatever orders they get, so they design the final product according to the orders or according to the specifications given by the client. So job shops, we can say, handle a variety of jobs where each job is different. If we compare it with batch production, in batch production there is a continuous demand for products. The rate of production exceeds that of demand and hence there are batches. So in the last session we had discussed that in batch production we had given the example that batch production is like a garment industry. So they are making a number of shirts, but here a tailor makes one shirt for you. So that is a example of a job shop technology. So they are handling variety of jobs where each job is different. But here in batch production, they are also handling different jobs. But here they are not doing they are not producing one single product. They are producing product in batches, in some moderate volumes. So job shop production, further we see the comparison in batch production, products to be made in different batches are predictable. Whereas in job shop, products and demand both are unpredictable. Then in job shop, products may be customized. So this is what we have been discussing, that in job shop you cannot predict what kind of demand will come, what kind of product will come. But to some extent in batch production you can predict, because you know what is the trend in the market today. So a garment industry is making some kind of garments in some kind of volumes. So you can predict what kind of demand, so by proper forecasting. But in a job shop, forecasting may not be very useful. So further we see that job shop production, in job shop we handle the unique jobs each time with a unique set of operations and processing time. Job shop machines are general purpose machines organized department wise. The sequence of each job is unique depending upon the technological requirement of each product. So like in batch production, you use process layout in job shop production systems. So because you cannot predict what will be the route of the materials. Each material is unique, so each material will follow a different rule. So you have to do different kind of scheduling, different kind of routing for each product. So job shop processes, you can say, are organized around a particular type of general purpose equipment that are flexible and capable of customizing work for individual customers. Further characteristics, if we see, its significant setup and changeover time is required, batching, low to moderate volumes, many routes, many different products, high workforce skills, customized to customers' specifications. Examples, many small and medium manufacturing companies are set up as job shop processes, as are hospitals, legal services, and some restaurants. So generally you will see many engineering workshops. They can make any kind of materials. Today you want some iron grills for your windows of your house or for your offices, for your factories. So you give the design and this workshop will fabricate those iron grills for you. So it's a job shop process. Similarly, when you go to a legal services company, so each case is different. So they may require different kinds of people, sometimes civil expert, criminal expert, and accordingly they will design the case for the client. Even some restaurants can be like that. Now we come to another kind of process technology which is known as project technology or project processes design. So a process technology suitable for producing one-of-a-kind products, large in scale and size, where resources are brought to the site. Now what is the difference between a job shop technology and project technology? In job shop technology you are making small products. You may be making small products, large products, but here in project technology, generally you are making very large products. Generally, resources are brought to the site. For example, construction. Somebody is constructing a building. It's not a, you can't call it a simple product. All the paraphernalia, all the materials, all the machinery, infrastructure, cranes, mixer technologies have to be brought to the site where you want to construct that building. So it's a project. So projects are large scale, customized initiatives that consist of many smaller tasks and activities that must be coordinated and completed to finish on time and within budget. Let's say the government wants to make a flyover. So it's a project. So everything, every paraphernalia has to be brought to that place. A highway has to be built. A metro line, a new metro line has to be constructed. So these are all examples of projects. So what are the other characteristics? It's again one of the kind, large scale, complex, resources brought to the site, wide variation in specifications and tasks. You can't say that a company is making a metro line. So there are different challenges. Sometimes metro line is on the ground, sometimes metro line is underground, sometimes metro line is on a kind of a flyover. So each task is different from others. Examples: legal defense preparation, construction, installation of railway tracks, consulting, software development, manufacturing of turbines, large machineries, etc. Now let us see a very comprehensive chart wherein we will compare the project processes, the job shop processes, the batch processes, the assembly line and the continuous process. So we are comparing all of them with respect to size. If we see in a project process, the size is variable. Sometimes the size may be very large, sometimes it is medium. In a job shop, generally the size of the product is smaller. In a batch production, the size is moderate. In assembly line, again it is large. In continuous, it is large. That is, volumes are very large. The process flow in a project, there is no pattern. You can't say it is a continuous process industry, it is in a zigzag fashion, because each product is different. So you can't say there is any pattern. In a job shop, there are several process flow. In a batch production, there are few process flow. In assembly line, there is very rigid process flow. In assembly line as well as in a continuous process industry, it's a rigid process flow. So the material has to follow that route. The speed with which you make the product. The speed in a project processes is variable. Sometimes the speed is slow, fast. In a job shop, it is slow. In batch production, it is moderate. In assembly line and continuous process, the speed is very fast. The speed to make the product, because generally automated machines are there. What is the run length? In a project flow, it is variable. In a job shop, it is short. In a batch production, it is moderate. In assembly line, it is long. As well as in a continuous process, it is long. What is the rate of change? The rate of change of materials, the rate of change of setups. In a project and job shop, it is slow. In batch production, it is moderate. And in assembly line and continuous process, it is high. What is the labor requirement? That is the number of labor required. In a project and job shop, it is high. In batch production, it is variable. In assembly line and continuous process industry, it may be low, because many times these are automated industry. What is the level of skill required? In a project and job shop, high skills are required. In a batch production, mixed. In assembly line, it is low. In continuous, it depends on the type of industry, so it is variable. So this has given you an overall idea about the comparison of various kind of processes. Now further, if you see this diagram, on the x-axis we have shown volume from low to high, on the y-axis we have shown the customization from low to high. So on the top we have the project processes. So if you see here, the customization required is very high, but the volume will be low. You will make one building. Even to make one building or one house, it will take a lot of time. So it's a project. Then if you go down on the chart, you have in the middle, you have and then job shop process. Now the customization is slightly slower and the volume is slightly higher than the project. Then you come to the batch technology. Now again the volume has increased, the customization has reduced. Then you come to assembly line, again now the volume has increased, the customization has reduced, and then in the last at the bottom there is a continuous process industry. Now here the volumes are very high but the customization is low. So for example, in a milk industry, it's making the same kind of milk day in and day out. It's a bread industry, it's a continuous industry, but the volumes are very high, but the customization is low. They have a set variety and they will continue to make that. In a project, the variety is very large, the volumes are very low. So therefore, if we see product flow characteristics, so we have seen that there is a line flow, overall there is a batch flow and there is a project flow. If we see the in terms of the product flows only. So if we see a line flow, in a line flow, once again it's another way of understanding it. In a line flow you have various workstation. Let's say you have WS, that is workstation 1, you have workstation 2, WS2, you have workstation 3, that is WS3. So the product will move in a set line, let's say like this. So the product is moving in one direction. So this direction, here we are showing horizontal direction, this direction could be a vertical direction, this could be a zigzag direction, but it is following whatever direction you are setting, it will follow that only. So this is called a line flow. So it doesn't matter, it may be a S-shaped direction, it may be a V-shaped direction, but it has to follow the same direction. Whereas in a batch flow, here also it follows a direction. For example, you have workstation WS1, workstation 2, WS2, WS3, 4 and 5. These are all workstations. And then at the bottom you are seeing product flows. There is a line, then there are dotted lines, and there is a broken lines. And if you see again on the top, there is a straight line. It is following route from workstation 2 to workstation 4. There is another batch which is following from workstation 1 to 3 to 5. So like this, at concurrently or at parallel, there may be 2 or 3 or 4 batches running together. So each is following a different route. That is called as a batch flow. Then there could be a project flow. In a project flow, there is no pattern as we have just seen. So for example, you are starting at this point, then you have to do task 1, then simultaneously another task 2 is taking place, another task 3 takes place. Here we can know that unless and until task 1 is complete, you cannot do task 3. Then task 4, so here you can see that unless and until you complete task 2 and task 1, you cannot do task 4. And then there is end. So end will come only when you complete task 4 and task 3. So this is an example, this is a diagram of a project flow. For example, the apt example for project flow is that, let's say you want to make a house. So you are starting, let's say task 1 is you have to lay the foundation of your house. So you are putting the foundation, you cannot do any other work simultaneously. You cannot start constructing the wall somewhere else and then you will put it over there. So unless until you have put the foundation, then your next task begins. Then you start constructing the walls. So that is your, say, task 1, task 2 is your constructing your walls. Constructing your walls, when you construct all the walls, then you lay out the roof. You cannot lay out the roof unless and until you have constructed the wall. So every process is dependent on the previous process. So there is a precedence arrangement. So that kind of arrangement is known as a project flow. Then we will again come back from where we had started in our last series. So various kinds of customer order. So one kind of customer order is makes to stock order, or MTS. Here when you are making these kind of products, there is a standardization. So such kind of products are made in either continuous process industry or in assembly line technology, makes to stock. For example, companies are making cars, motorcycles, refrigerators, televisions, computers, mobile phones. Companies are making food items like ketchups, they are making juices, they are making cold drinks. So these are all made follow make to stock. So either continuous process industry or assembly line industry. So here the idea is they have to create the inventory, and then once they have created the inventory, they have to push to the market. They have to send it to their distributor and dealers, and finally to the retailer. Second kind of products are called make to order products, or MTO. So market pull. So when market gives you the order, then you start making it. So any industrial kind of they take industrial order. For example, an industry is giving the order that you make a machinery for me. So they will make it accordingly. So then the third one is called assemble to stock. That is called mass customization. So they are assembling. So they get the order, already there are some materials, and they assemble it whenever the order comes from the market. And then there is another theme called engineer to order. Engineer to order requires very high customization, engineer to order. So basically make to stock, assemble towards stock, and engineering to order. So as you move in this process, you are moving towards more customization. So what are the advantages of make to stock? In make to stock, the advantages are that you create inventory for peak demand. For example, companies who are making ceiling fans, table fans, air conditioners, coolers, so they will not make only in summers. They start making it in winters, so that when the peak demand in summer comes, their material is already in the market. So make to stock means they have to create inventory for peak demand. But what are the disadvantages of make to stock? Inventory cost. They have to invest, before time in the inventory, and they have to stock it and they have to put it in the market. And sometimes there are obsolescence cost also. Sometimes if the material is, for example, if it is a medicine, if it is a food item, there is an expiry date to it. So it may become obsolete after some time, it may expire after some time. So these are some of the advantages also, disadvantages of these goods. So now if we see product life cycle stages, what various products are of various types. Some products are low volume, low standardization, one of a kind products. Some products are made, they are of high variety, that is multiple products, but they are made in low volume. There are some products which are characterized by few major products but higher volume. And some products high volume and high standardization, for example commodities products. Then similarly there are various processes, life cycle stages. So as we have studied, there is a job shop process which follows a jumbled flow. There are batch production systems, so it follows a disconnected line flow. Then there is an assembly line process which follows a connected line flow. And then there is a continuous flow. Now if we combine all of these together, we will get this kind of a chart. This is known as product process matrix. So on the top you are seeing the example of window grills. So these window grills, this follows a job shop kind of a technology. So job shop kind of a technology, it follows a jumbled flow, and these are one of a kind product. One of a kind means different people will give different design and different kind of products will be made. Then next comes your products which is following a batch technology. Let's say a garment industry. So a garment factory, garment industry, so it is following a batch kind of production. So the volume is now more than a job shop, and it follows a batch process technology. Next comes the automobile assembly. So automobile assembly is following a assembly line system, wherein again now the volumes have increased and it is following a assembly line technology. And in the last, sugar industry, paper industry, so they are characterized by high volumes, low customization. So you have seen all those things in totality, and so to summarize these things, by the product itself, now we can know what kind of process is required for that industry. So if it is a product which is made round the clock and number of products are made, it is following a continuous industry or a mass production system or assembly line technology. If the products are not used round the year, they are being made according to the order, but they are made in medium volume, so it is a batch technology. The third one is a job shop technology, because you are making a single product for the customers to cater to the customer client, so it is a job shop process. And the fourth one is a project technology, which is again a one of a kind, but it is of a very large nature. You are making a defense of a country is making a specialized plane, a combat helicopter, so it's a one of a kind helicopter. So all the resources have come to make that particular product, so it is following a project technology. So these are the various processes. So all these processes will help us to understand the further concepts of operations management.